Good afternoon and good evening, everyone, and welcome to the Cities on the Frontline speaker series session. Today, our session is on harnessing benefits of communication infrastructure. I am Isabel Parra, and I'm from the Resilient Cities Network. Today, I'll be co-hosting this session with Dr. Paul Dixon from Duraline. So before we begin this session, I would like to give you a quick introduction to the series and some ground rules to take over the session. So Cities on the Frontline, it's a virtual thought leadership speaker series, and the intention is to future solutions by cities and for cities. The series provides a platform for city practitioners to exchange knowledge, and this today is the 11th session of the series of 2023. And today we're co-hosted by Orvia and Duraline, and I'm really excited about this session because by partnering with Orvia and Duraline, we're able to bring together the experts from cities and these different sectors that sometimes it's so embedded in our cities, but we bring different ways and thought-provoking topics that will help cities build resilience infrastructure. So as I was saying before, we're gonna talk about communication infrastructure and how it can bring co-benefits to embrace resilience in cities. The purpose of this global seminar is to have an honest conversation, and we're recording today's session, but we ask you, if you're going to attribute some of the comments to the speakers, please contact us and we make sure to have the permissions needed to do this. We have around 170 registered participants today. So to facilitate the discussion, the Q&A function of Zoom is open, and we ask you to please ask your questions there. And we hope this session will be as interactive as possible. So Paul, over to you, and welcome again, everyone.
Okay, so let's see if technology is working today. I'm going to share my screen. And I'm assuming you can now see my screen. Yes? Good. Okay, so we have an awful lot to cover today in a short amount of time, so we're very excited. I'm very excited. It's an honor to be participating with Resilient Cities and discussing this very important topic with you city leaders all around the world. First, a quick introduction for me. I'm the Director of Business Development for Duraline. I'm also the Chairman of the Board for the nonprofit Fiber Optic Sensing Association. My quick background is I've been in the industry in telecommunications and technology for about 30 years. For those of you who don't know Duraline, they're the global leader providing conduit pathways for infrastructure for over 50 years. We'll talk a little bit about those today because they're part of infrastructure. And I welcome and encourage each of you to reach out personally after this webinar to follow up regarding how we can work and how the panelists here can work with your cities. My contact info is listed here on this page. We have a lot to cover in a relatively short time. My intention, and what I've been asked to do, is to start us off by providing some framing background and context that our panel will then dive into for the rest of this discussion and Q&A. But before I do that, I want to briefly read a short bio from our panel of experts that I'm very privileged to be with today. For each of the folks on this call, David Basto. David is the leader for Calgary Smart City Program and is building the Technology Integration Center to accelerate experimental culture at the city. City of Calgary is a member of Resilient Cities, which is amazing. And by the way, and David has an extensive experience in municipal networks, communications infrastructure, and telecom regulation. Kyle Glazier, with a network design engineering background. Kyle's a director of emerging networks at a very novel and exciting company named Underline, and focuses on developing network architectures that are customer tailored to a community's infrastructure needs. He has a keen interest on developing network use cases with respect to open access networks. And then finally, John Williams, or JJ as he likes to be called, is the global commercial director for Luna, and he's been involved in optical fiber-based technologies in a wide variety of vertical markets, including those pertinent today, telecommunications and utilities. And with expertise in infrastructure monitoring, he's been involved in many projects, standards development, public policy, and currently also serves on the board at the Fiber Optic Sensing Association. So I don't need to tell this audience much about resilience, but I needed to brush up on it a little bit before this talk. So I took some time to research and explore this on my own with the wonderful materials that are on the Resilient Cities website. The definition I found was surviving, adapting, and growing despite shocks and stresses that are impacted or exacerbated by global trends that we're all too aware of: climate change, urbanization, globalization. So this is a great definition of resilience to get us started. I also wanted to align on several key pain points, because it's all about the pain points, right? And how to resolve those, that cities and communities all around the world are currently experiencing. So I know there are many more than this, but post-disaster recovery, preventing, minimizing, and alerting to risk of disasters, ensuring in scarce supply we have enough adequate resources, energy, water, connectivity, and then, of course, reducing digital exclusion, enabling cities and all citizens to thrive and grow. And then getting to this topic, ensuring that the communications infrastructure is robust, reliable, flexible, and future ready. And then finally, if that wasn't enough, maximizing the impact and doing this all with very limited available funds. So I encourage you to explore a very detailed report I found in my research that was just released on the Resilient Cities website, October 2023, that talks specifically about digital resilience. And I wanted to mention that. It's called Digital Cities, Resilient Cities. And there were a few takeaways that I want to share with you from the report. They talked about the ability of your infrastructure in your city to respond to challenges. It needs to respond to predictive capabilities and enable that if possible, and all within a complex interdepartmental system. There are multiple stakeholders, as everyone on this call knows, and it's not an easy task unless you do that with a lot of planning and a lot of collaboration and coordination. So don't try to read this. Maybe in the archive of the discussion, you'll be able to go back and look at what some of the words are here. This is a very detailed picture with graphics of buildings, businesses, homes, cell towers. The only takeaway I want you to have today on this very busy infrastructure map is the awareness of all these little connection lines between the graphics. The connection pathways are made of conduit and fiber cable, which essentially tie together everything. So what do the pathways do? They provide direct connections point to point. They provide passive optical network split connections where you get your broadband delivery. And they provide the critical wired backhaul that enables wireless cell technology to work. So in short, the main point here is that fiber cables connect everything in your cities, even enable the wireless that we all so readily rely on. Now, what are some of the key considerations associated with digital resilience or the lack thereof? So there are connectivity gaps in areas that don't have reliable service. Unfortunately, these are typically the lower income and remote rural regions. But the good news is that both public and private sectors are now motivated to address this digital divide by expanding network access. Governments increasingly see an opportunity to drive growth and level the economic playing field for its citizens, while the operators, the ISPs, or the service providers also have demonstrated a desire to invest in these gigabit-capable services, the symmetrical services we all need to maintain at a competitive advantage. And then, of course, we're all too aware of what the global COVID-19 pandemic has done to accelerate this urgency, and so we have to address it. Now, the good news is funding is increasing. I direct you to the gray box here. Globally, there's an increased level of funds available or soon to be available to help enhance digital infrastructure. Hundreds of billions of dollars globally for many parts of the infrastructure. The need's tremendously strong and planning is happening rapidly, but the cost can still be a huge obstacle as you, as city planners, strive to provide this to all your citizens in the community. Here are some really, I think you'll find interesting growth statistics so you can see just how fast this is happening globally. Bandwidth global consumption rose 165% from 2017 to 2021. Fiber implementation, the preferred medium of choice, has grown more than 35% since 2019. In fact, the US alone is expected to deploy, and listen to this, more fiber between 2022 and 2027 than it has deployed to date, historically. So fiber investments ramping up all across market segments, and that's why this topic is so critical today. Now, many city planners don't know the detail of how to build infrastructure. I wouldn't expect you to. So I thought I'd briefly show you just part of it today. For those of you who haven't seen it before, this is what a conduit pathway looks like in a cross-section. Fiber optic cables, those are the black cylindrical pieces in the pathways, live within a plastic duct. This is the orange part that's either one hole like the one on the right or subdivided like the four on the left. This is placed throughout all our cities, either under the ground or on poles. As simple as this system is, and as you saw in the earlier graphic, this is the optical pathway system that makes digital connectivity possible. Without this, you don't have it. And the design and selection of these materials matters greatly for the topics that the panelists are just about to address. So just super briefly, I want you to be aware of a few things. Compared to standard cables, the modern smaller microcables, like the four that are on the left, they're much smaller, they're lighter, they're more fiber dense. In fact, each of those little black pieces can hold as many as 864 fibers in one single cable. They take up less space, so you can install more over time, and they're easier to handle, and it requires less manpower. And one of the big constraints we have in growing out in your cities, I know you're certainly aware of this, is the manpower shortage. I mean, that's a critical limiting factor going forward to build out broadband. These smaller cables are also faster to install. The other important point I want to mention to you is infrastructure is never static. There was a time when people thought, I'm just going to put fiber in, I'm going to put in a bunch now, and that's going to be enough. You will need to add fiber based on increasing demand, but you won't know where. You won't know where it's going to be needed. You're not going to know in what route it's going to be needed. So with that basis behind you, for a modern pathway design using this micro technology, you can add new fiber cable in empty pathways and wherever it's needed without digging up the ground again, which is the most expensive part of construction. And this makes future upgrades faster, simpler, and lower cost. This is something you as cities planners really need to be aware of. So moving on, number 4 is a very important point. So I'm just going to read it verbatim. It's critical to be aware upfront, and that's today, of both the financial and technical opportunities in the design and implementation of the infrastructure so that you can enable opportunities rather than limit them down the road. This is one of the key takeaways of this entire session today. So as I just pointed out, the design and composition of products and materials matter greatly for future flexibility. Also, here's another factor. It matters geographically where you install the infrastructure. If you need to install the installation locations now so that you'll enable not only the broadband use, reducing the digital divide for your citizens, but also enable the other multi-use applications you're about to see. So this is going to pay dividends in the future. And one other point here is that while new installations in your cities may be the most important and the most considered right now, it's important to note there's also a tremendous opportunity to use your existing conduit and fiber infrastructure already for the purposes we're going to talk about. So by considering a plan through a well-planned technology roadmap, which I'm sure many of you are embarking on right now with all this funding, you're able to leverage these additional opportunities. What are they going to do for you? They're going to minimize future infrastructure build costs. You're going to be able to use the conduit and fiber infrastructure to reduce ongoing operating expenses and your future capital expenses. And then, and this is one of the most exciting things for me, you're going to be able to use these new technologies in a total solutions approach that'll enhance life safety, increase security, enable predictive maintenance within your city, and help reduce costly or even catastrophic damages. So this doesn't happen in a vacuum or by itself. This only happens with intentional planning, gathering all your key stakeholders together to look at all the possibilities and assess how to share in the advantages. So considerations include your right-of-ways that are common, capacity sharing or leasing opportunities, I think maybe David may talk about, the ability to monitor and protect for the benefit of multiple stakeholders in a very cost-effective manner. And this is going to require citywide coordination, and it starts with you. So please reach out. I encourage you to talk to the experts on this panel for guidance on how best to get started. And to close out the introductory part of this session, our citizens and our city services need a robust and a future-ready conduit and fiber cable infrastructure. We're going to have to build it sooner or later, and we're going to need to creatively find a way to pay for it. I strongly suggest we coordinate amongst ourselves and work across all our silos to find a way to maximize the current and future utility of valuable infrastructure in all ways possible. And with that, let's start the panel discussion. I'm going to reach out with the first set of questions to the panelists as I co-moderate the rest of this presentation. So the first question I'm going to have is for Kyle. Kyle, how would you describe smart communications infrastructure, and what is in practice now or possible within cities to enhance urban resilience? And where are we now with that effect regarding the work that you've done within Underline? So I'm going to go to your first slide, Kyle.
Excellent. Thank you, Paul. Like Paul said, I'm Kyle Glacier. I'm the Director of Emerging Networks at Underline. So I want to talk a bit about what a network is going to be capable of in the future and how we should look at designing networks to be prepared for those applications, and then compare that to what exists today and what's being done in network design today. So I believe that networks that are designed to maximize future applications are foundational to community flourishing. And the world needs more than one kind of network. We've become dependent on a network that was designed for a very useful application, access to the internet. However, the capability of networks goes far beyond that. And as we expand into different types of smart cities around the world, it's important that our networks are designed with those ideas in mind, with those applications in mind, and that they have a appropriate physical attribute to them and software attribute to them that allows for these applications to be deployed efficiently. So if you'll go to the next slide, we can talk about that. So sorry, one second.
It's changed.
There we go. So yesterday's networks are single purposed. This means they're designed for a single application. Like we just said, for the access to the internet is a single application of the networks right now. Yesterday's networks are vulnerable. Not every edge on a network is the same. So as we deploy different types of IoT solutions or sensing applications across networks, their type of connectivity is going to be important to ensure that they are not expanding the threat plane by which communities can be attacked by bad actors. So this means that getting access to those edges are blocked by the way the network is physically designed and are blocked by software for malicious actors. Yesterday's networks are static. It's a high CapEx exercise to update those networks, to add routes to them, to increase the bandwidth of them. And this is because of the way electronics and different types of splitters are distributed across networks today. Yesterday's networks are designed in a silo. So lack of communication between multiple stakeholders inside of a community during the design process of a network results in a network that doesn't have physical close proximity to the types of applications it needs to be solving. So this could be distance from water utilities, distance from electrical grids, or traffic monitoring solutions that aren't near the road they need to be on. So let's talk about tomorrow's networks. Tomorrow's networks are application rich. So these are networks that are designed with more than just internet access in mind. They're designed with educational networks in mind. They're designed with telehealth in mind. They're prepared for IoT deployments. They're ready for distributed acoustic sensing. They're able to attach smart buildings in a meaningful way. They're enhancing public safety. They can provide guidance in a disaster, and they're resilient. Tomorrow's networks are cyber secure. Every type of application that can be brought onto these networks require a type of connection that is specific for that application to ensure that it cannot be breached through a bad actor. So this is ensuring that your network is providing dark fiber where it's appropriate, or a layer 2 connection where it's appropriate. It's using software-defined networking to dynamically create routes where it's appropriate, and it's delivering millimeter wave and mesh technologies to ensure connectivity across a broad area for different types of applications in home use. Tomorrow's networks are dynamic. That means that they are readily upgradable. You know, more and more chassis are coming out today that have plug and play electronics that allow for networks to increase their speeds dynamically. But also, there's some thinking that goes beforehand around where networks are spliced, how they aggregate traffic, to ensure that as you bring new routes on, new customers on, new areas of your city, that there is an appropriate amount of bandwidth and fiber is available to reach those communities. And tomorrow's networks are integrated with other types of infrastructure. So that means that these networks are planned with all of the other types of infrastructure in the community in mind. So they're taking into consideration the proximity of water lines, electrical lines, roads, and all of those things. And then they are designing the network to be, one, in close physical proximity to those, but also to take into consideration what types of applications that particular community might need, and ensuring that the fiber is appropriately designed. So with that, if you'll go to the next slide, and we'll look at a couple of examples. This is an example of yesterday's network. So this would be a traditional kind of fiber to the home deployment. The network is this yellow line going across the graphic here. And this was designed with a single purpose. The designer of this network was looking at these homes and trying to figure out what's the most efficient way to get internet to these homes. And the most efficient way to do that in this case is to avoid other utilities. Here we see some blue water lines. We see some red electrical lines. We see a major thoroughfare road. And this designer decided that their goal was to deploy this network at the lowest cost possible in order to attach as many homes to it as they could. So avoiding those utilities and avoiding that major thoroughfare became the goal of this design. But the result is, this is a network that cannot perform smart city applications for these other utilities and other types of infrastructure. And there's a high cost to bring those into the fold later on. So let's compare that to what tomorrow's network should look like. This is a very small change in how this network is designed. But what was done is all of these other utilities and these road systems were taken into consideration as potential revenue sources in the future, and also to ensure the community had a thriving smart city plan. So now this network is in proximity to the water lines. It's crossing the highway here in a meaningful way so that it can perform signal control and traffic monitoring. It's staying adjacent to the water line as it goes to this water tower to ensure that it can perform water leak prevention for this route. And it's still serving all of these homes with fiber to the home. So this is a multi-architecture network with different types of splicing availability and multiple types of functions. And it's got future capacity built into it for all of these different applications. Future capacity can look like a couple things. One, additional fiber left inside of the plant, but also a well-designed conduit network is the basis for most functioning networks, I believe. So having, like what Paul was describing before, future paths built into your conduit network, and additional conduit set aside to provide what we like to call dark air for future expansions is absolutely imperative. So that's what I have today, and thank you, Paul.
Yeah, thanks, Kyle. That's awesome, and very nice illustrations. Less slides or sometimes more, and this makes it very clear to me. Hey, David, I have a hard time with that, by the way. David, do you have any comments verbally on this before we move on to the next question?
Yeah, I think Kyle hit it right on the head there. Especially when it comes to this fiber infrastructure is more than just broadband. There are a lot of different types of network that uses fiber. And the way the Tomorrow network that he showed is actually how the City of Calgary does it as well. We look at the routes that we take, we hit traffic controllers, police stations, fire stations along the path, and we plan out our infrastructure in a very similar manner. And it does reduce costs dramatically. And so, but I'll talk about that later. Yeah.
Okay. Thanks, David. Okay, let's move on. Considering the time, I'm going to move on to JJ from Luna. JJ, here's the question for you. Innovative applications of communications infrastructure are emerging as we're starting to talk about now, to enhance urban resilience, such as the use of fiber optics for other applications in the domains of real-time monitoring, damage prevention, and disaster early warning systems. Can you describe what's happening and also comment on the positives and negatives and any concerns we may have that the city leaders may have, such as privacy, regarding the implementation of these technologies?
Yeah, I'd be delighted to, Paul. So yeah, technology, plays a huge role in digital resilience, and there's a number of different technologies available to cities. And in terms of privacy that you asked about, they're mainly, technologies that can identify people, cameras, biometric scanning, processes around ID cards and things like that. But there's many technologies and sensors that just detect events and things occurring from an operational standpoint that have no way of recognizing individuals or things like that. Everybody's heard about Internet of Things, and it's been talked about at great length over the last decade. I wanted to say that there's a kind of a new paradigm or new opportunity in terms of technology for digital resilience, which is called distributed fiber optic sensing. We've been talking about smart communications infrastructure, and that's imperative for resilience of cities to have good communications. But fiber networks are not just available for communications, they're also available for sensing. So dark fiber is all around us. It's along our infrastructure, it's along highways, it's along bridges, it's in tunnels, providing communications. But with distributed fiber optic sensing, you can use that cable also to monitor those assets using optical sensing techniques. And this graphic on the left shows one of those units and how it can convert a dark fiber into an array of sensors just using light in the fiber. And that can give us different signals, and which lead to different applications. And the main applications for smart cities are monitoring traffic flows along roads, monitoring for security applications, along rail lines, metros, or facilities within a city, monitoring utilities like power cables or gas lines or water lines for issues. And then providing safety benefits like fire detection. So I'm just going to run through some use cases of an example of an innovative technology that can help with the resilience of a city. Paul. So this is just dark fiber that's a communications cable relatively close to a metro line. This is in the suburbs of London, actually. And, there were great concerns around the London 2012 Olympics about security. We were also seeing a spike in copper cable theft because the price of copper as a commodity was very high at the time. So organized crime was actually stealing the copper from these electrical cables. Which sounds crazy, but must make economic sense if they're going to be out there doing it. So just using fiber in the same duct bank or troughing, we're able to detect that human activity from a security standpoint. And this has become very widely deployed, in cities like Montreal and in Asia for metro security. Because you have sterile zones, where people shouldn't be, particularly on.
I hope those on the audience can hear the squeaky noise. That is not my chair. That is someone sawing on the rail, trying to do something nefarious in the area.
Yeah. So next use case, please, Paul. So buried assets, fiber, utilities. you know, typically there's no live monitoring. You know, there's normally somebody reports, oh dear, you know, there's somebody's dug into a buried cable or buried power line. So it's after the fact. There is a way using fiber in a right of way to actually get early warning of people in the right of way doing construction activity. So this is a huge problem, you know, economically, in terms of damage to buried assets. You'd be amazed how much cost it creates from that damage. You can also set these systems up to monitor specific locations like manholes and see, you know, you can create a zone around and say, we have a manhole here. We want to know if the manhole's been opened or closed, and if it's our maintenance team or somebody else that we don't know about. Next slide, please. In seismically active areas, you know, dark fiber all around a city can be an incredible seismic array. It's long distance, it has high granularity, and it's instantaneous detection of seismic activity, just using communications fiber across the city. In this example, this was from the west coast of the USA. You're getting just, you know, background noise of a city here, vehicles, other activities. And from left to right is around 100 kilometers, which is the range of, you know, these kind of systems. And you can see a very clear event here, obviously. There's actually two waves there, a P wave and an S wave of an earthquake. And, you know, while that's all, you know, nice, pretty acoustic data, what is the application? Well, the application is that it can trigger an alarm, and it can trigger that alarm within, you know, milliseconds. And that can go to a wider early warning system that a city or a region may have in place, okay? And you'd be surprised, but, you know, 10 seconds in an earthquake situation is quite important. You know, there's a lot of things that can happen. People can get into a safer location in 10 seconds. So these are the kind of things that cities and regions are looking at to provide better information to their populations about emergency situations. Next slide, please. So in this example, this is buried infrastructure. This is a transmission line feeding Manhattan in New York City, and that's the Hudson River. And this transmission line is absolutely critical. It's feeding a major substation where, you know, half of the island kind of derives its power. So by acoustically monitoring the fiber embedded in this cable, we're able to monitor for things like anchor drag or for storms, storm surge, you know, moving the cable, things like that can reduce its resilience. So that capability can be integrated with the AIS system, which is a way of tracking vessels. And all boats have to have an antenna that's reporting to the AIS system, so that people can identify who's out on the water. It's a safety thing. So with that integration, cities and operators of critical infrastructure can see, you know, there's a cable that's being damaged by an anchor, for example, and which vessel it might be, so that they can communicate with that vessel. Next slide, please. Traffic monitoring. One side of the road typically has a fiber. We can monitor both directions of traffic flow using fiber optic sensing. This can tell you traffic conditions, whether there's congestion. It can tell you traffic volumes, and it can tell you whether there have been incidents. So if you compare that with point sensors, you know, there's a point sensor here and a point sensor there. You know, we're providing distributed sensing, so there's no gaps. It's every few feet there's a data point, even though it's just light in a fiber. So this is being deployed across the US and in Western Europe and in some other parts of the world to augment point sensor traffic monitoring, fill gaps, where there may not be other sensors, and help transportation departments understand their roads better. Next slide, please. For example, we saw on one of our systems a very clear output in terms of traffic volume and density before COVID versus after the COVID lockdowns that we all enjoyed. So that's very useful for cities and for transportation departments to understand, how much, different roads being used. Does that data correlate with what, we thought was happening out on the streets? So this is like a heat map of traffic. You've probably seen this on like Google Maps, which is used primarily with probe data. Probe data is from people's cars and Bluetooth and things like that, and their phones, basically. But it's only a certain sample rate, whereas we're getting 100% of vehicles that are passing up and down these roads. Next slide, please. This was more of a tragic example of city resilience, where there was a bridge collapse in Genoa. It was pretty catastrophic with some loss of life. The bridge has been replaced, and it's been fully instrumented with fiber optic sensing to monitor for structural health, and I would say it's become pretty standard now for bridges in the last 15 years constructed to have fiber optic sensing on them. So those are a number of different use cases of how fiber that is already out there or is being newly installed can be leveraged for resilience as well as communications. And that resilience can be through monitoring the structure of a bridge, monitoring traffic flows, and ensuring that escape routes from a city are clear during an emergency event. Monitoring facilities such as buried utilities and so forth. So city planners and stakeholders and utilities should always consider technology as well as communications when they're making these investments. Okay.
Thanks, JJ. In the interest of time, we're just a little behind, but I think we're going to be okay. I'm gonna go right to David and his question, and then Kyle and David, if you have any comments on what JJ has just presented here, let's integrate them in just a minute. So this is for you, David. For you and the wonderful work you've done with the city of Calgary, what are the benefits of municipalities with respect to owning and operating their own fiber infrastructure? As one of the pioneers, how can other cities build out their communications infrastructure?
Well, thanks for having me, Paul. And I'm just gonna emphasize some of the things that Kyle said, and actually I'll talk a little bit about what John said as well in my presentation. But on the first slide here, you can see City of Calgary has a lot of devices connected. But when it comes to the business case of building infrastructure, cities really need to think beyond broadband. And this is what Kyle was talking about. So in fact, I would say for a large city like Calgary, broadband is the weakest argument to build fiber infrastructure for a city, because generally in a large city, broadband is taken care of by the carriers, but cities have huge connectivity requirements and are in the best position to cost effectively deploy fiber because of all the capital projects we work on. We work on a number of linear assets like roads, water, light rail transit projects. In our city, we connect over 900 sites with fiber. 345 buildings, 565 field locations. Those can be like traffic controllers or sensors, cameras. And we have approximately 650 kilometers of fiber in the ground. The city has been deploying fiber since 1997. So, and demand for bandwidth and security has never ceased. We're at 100 gig backbone, which is quite common. Upgrading probably to 400 gigs fairly soon. 800 gigs is just around the corner, and 1200 gigs or 1.2 terabits is just on the horizon. So these speeds can't be replicated over wireless technologies. So fiber is foundational. From a cost savings perspective, there are many ways to look at this, but the simplest way I find is to just compare the cost of looking at what it cost us to lease fiber when we first started, and what would it cost us to lease fiber today with all the infrastructure we have. And today, if we were to lease all our fiber, it would cost us $30 million a year. Now, next slide, please. So as what Kyle was saying, cities operate numerous networks. Roads has a network, transit has a network, water, IT, and sometimes even business units have several networks. So what I'm showing here is just one network. It is the main transport network that our department operates, which can aggregate a lot of the different types of networks and transport it across the city. And this includes also wireless networks, because with our fiber, we can now stand up towers, have fixed wireless, Wi-Fi, and even a LoRaWAN network, which covers most of the city, and we can use for all our sensing applications. Next slide, please. When it comes to managing fiber and the resiliency of a city, when we provision our dark fiber to the community, other network operators can pick it up and use it to create resiliency in their networks. So for instance, the health region uses city fiber and carrier fiber to create a diverse and resilient network. We also supply dark fiber to solar farms and other renewable energy generators. City fiber is used to build the Calgary Internet Exchange, which is, and they've just upgraded to 400 gigs on their network. We also provide dark fiber to universities for research. They've done a lot of research in quantum computing and quantum encryption. And we're testing also fiber optic as a sensor and DAS. And as you can see there in that graphic there, we can test and see how our trains, the velocity of our trains, the position of our trains, estimated time of arrival. It can even show us how many cars are in that train segment. We can differentiate between a 3-car train and a 4-car train. And in the square box there, you can see what the effects are on one of the bridges when the train goes over it. So we can see what those vibrations are. So I'm very interested. One of the other aspects of DAS is that one reason why I really like it is there's no active equipment in the field. So if a fiber optic cable, which is actually a passive piece of infrastructure, can act like a sensor every meter, but there's no active equipment in the field, it really reduces operating costs and maintenance costs for the future. So that's pretty impressive technology. And thanks for presenting that, John. It's very interesting. Next slide, please. So some of the, one of the projects I'm working on now is called the Technology Integration Center. It's basically a lab for the city to try and deal with all the evolving technologies that are coming at us at a very rapid rate. And this pace of change is considerable. Artificial intelligence, robotics, electrification, all of these are disruptive technologies. In this facility, it is going to be on a separate network, not the same network as the city's network, but a safe place to experiment and test and prototype new technologies and how they apply to city businesses and services. As you can see in the bottom left-hand corner, I've highlighted one of the resources we'll be connecting to is a supercomputer, one of the fastest supercomputers in Canada, with our dark fiber. And this is going to provide huge capabilities for our business units to test new technologies in a hyper supercomputer environment. So this facility is going to be hyper connected in other ways as well. With our dark fiber, we can connect to all the post-secondaries, nonprofits, different types of, most of the commercial data centers in Calgary are connected with city fiber. So we have a huge amount of resources available to us that we can put on a private network that doesn't even touch the internet. So yeah, that's all I have for today. Thank you.
So thanks, David. You guys certainly, you gentlemen certainly complemented each other with the information provided here. You know, it's all about the technology and it's all about the business case. And so the cities who are listening here today, you know, you got some experts here that would be happy to talk with you and work with you on how doing this is going to complement and enable your monies to go further. And with that, I am going to switch it over to let's see, who am I switching it over to?
Me, to Isabel.
Yeah, hi,
Hi, Paul.
thanks for some Q&A, and hopefully we have some Q&A from the audience here. So I'm gonna hand it over to you.
Yes, thank you very much. It has been a lovely and wonderful conversation. I have a double question, let's say, and I'm gonna join two questions for David and Kyle, so you may ask and give us your comments. And if we have time, maybe we open for a third question of the audience. So I would ask, through all the conversation, we see this amazing technology that the cities, as you already mentioned, have it in their buildings, in their bridges, in everything is there. We have the technology, but you also mentioned some complexities and how to transform and leverage better this technology depends on partnerships and creating different alliances to deploy this infrastructure. So from a city perspective and understanding the complexity of the governance structure, how do you deploy this better and what have been the learnings there? And I would add a little bit, if you can touch upon the part of security that John touched a little bit, but how do you also convince the residents and your citizens that this is the technology to have, and how do you communicate to them and generate that awareness? Thank you.
So I'll take that question then. So when it comes to different regions, every city is going to be different. So, and every country is different because they have different regulatory environments and different industry environment as well. So I can speak to Canada, Alberta, and I think that municipalities, if you're a large municipality, you have a business case to deploy fiber quite pervasively. If you're a rural community, then broadband and internet plays a more important role in justification in deploying fiber. But I think the disconnect is that regulation doesn't support open access fiber. And so governments, both federal, provincial, and municipal governments, need to work together to align digital infrastructure strategies together to ensure that there's enough open access infrastructure and that that infrastructure is supported for rural communities. And to interconnect, even to interconnect large urban centers, like let's say between Calgary and Edmonton, which are the two large cities in Alberta, interconnecting those two cities with open access fiber could also feed all the rural communities along the way. So yeah, there's a number of things that can be done, but I think the first step is for all three levels of government to work together on a digital infrastructure strategy, and then affect policy and regulatory change.
I couldn't agree more. Coming from a private industry perspective, you know, Underline is a private business. We finance and operate and construct these types of networks, and we do build open access fiber optic infrastructure. And I do believe it's incumbent on some private industry. In most cities, private industry is going to be a large factor in the deployment of networks, right? So I think it's incumbent on us as a private entity to engage the city, engage the multiple stakeholders, even if they don't necessarily have a regulatory framework in place to be working together or a overall technology plan formulated. I can still go to each department and say, what are your dreams? You know, what are the things that you want your city to be able to do? And take that into consideration in the design of my network. And so the goal of the things I design are to interconnect all of the various networks that David was showing, as well as perform, you know, other features for the residents and commercial entities within that community. And ultimately, if it's done appropriately, that arrives at a private industry being able to generate more revenue off of those use cases and benefits the community as a whole.
Thank you, Carl. Now I'll continue with a question from Vibhuti that was posted on the Q&A of Zoom. So they ask, normally in Africa and Asia, the doorstep level internet connections are wired openly to access connections. Under these circumstances, how to ensure internet connections are resilient to the current disasters experienced in the region, like floods, cyclones, or earthquakes?
So can you say the first part of that question again?
Sure. Normally in Africa and Asia, the doorstep level internet connections are wired openly to access connections.
Okay.
Yeah.
Well, I would say that fiber is the most resilient communications method, and that, you know, anywhere that you can, the closer you can get fiber to the doorstep, the better. You know, buried fiber typically, you know, has a life cycle of 30 to 40 years. You know, Paul would also say, particularly in conduit, you know, that you would extend that life and have serviceability and future proofing of, you know, fiber needs through conduit. So fiber to the home is obviously a massive, you know, push in you know, certain parts of the world. If that's not available, then you have to protect your access points, and you know, you have to make them robust and resilient. And but yeah, you know, I would say fiber is the best option.
I would add to that whoever the entity is that manages that core network, the fiber components of that network, it's important for them to have a way to receive input from the communities that they're working in. And so if there are resiliency issues with the edge of a network, there's a lot of ways to solve that beyond just fiber to the home deployments across large geographies. However, obviously that's the gold standard, but it's important for the managing entity of a network like that to understand the potential applications and the future applications of this type of network, and to have, either through design consultancy or in-house expertise, an idea of how to add redundancy and resiliency into the core of their network to ensure that in a disaster setting, the central components of the network do not fail, which will result in a more resilient edge as well.
Yeah, I agree with everything John and Kyle just said. I think fiber is super resilient. It's not the same as wireless, and it's not the same as copper. So if you do have fiber, like in the flood of 2013 in Calgary, I literally had fiber patch panels, which are access points underwater, under muddy water that never failed, which is remarkable. And so I think the biggest problem is going to be power in times like this. We have floods and earthquakes and things like that. And of course, if there's no power, then there's no communications. But even with dark fiber, you can increase the resiliency of your power grid just by the way you can communicate with the grid and make it more resilient. So fiber makes power more resilient, but it also makes communications more resilient.
Yes, we continue with another question, and is how are new networks being designed for resilience with redundancy paths and no single point of failure architecture?
Yeah, I mean, if they're completely new networks, then there's all sorts of things you can do to increase the resiliency and redundancy. Depending on the size of the geography, you should have a certain number, but always at least two kind of central offices have redundant or even tertiary backhaul from those central offices to an internet exchange. Work with different carrier networks, or if you have the capacity and scale to build your own, then that's a good feature of a redundant network is redundant paths to internet exchanges, which is where the internet comes from, loosely speaking. At the edge, the more you can have what we call kind of multi-ring architectures, where there's just crisscrossing paths across great distance that are software defined, so that if a path goes down, the software can tell the network, hey, that we're now using this path. These failovers can occur in milliseconds, and you lose no information across that network. Those are the types of things that will allow a network to fail, because a network will fail. It'll fail successfully with those types of redundancies in place, and then you have time to go and repair those pathways while the alternative pathways are lit. And there's emerging technologies that allow all of that to occur even at the residential edge. And I'd say some of those are on the horizon. Some of those are here today. At Underlying, we do a lot of that with a particular type of software we've developed. And we choose network architectures that most mirror the core of networks today. We believe that innovation occurs from the core to the door. So all these magical things are happening in large data centers and internet exchanges. So the more you can mirror those network architectures into the final edge of your network, the more likely you are to benefit from the oncoming innovations in the networking space.
And if your fiber network is, having issues because of physical damage regularly, then fiber optic sensing provides live monitoring, of buried and aerial cables, and can prevent or detect and locate where physical damages are occurring. So that if physical damage is an issue.
I think the question also speaks to open access infrastructure and its importance, because diverse routes can be extremely expensive. But if we put that in our planning and urban planning design to have open access conduit, then you can create diverse routes very inexpensively.
Thank you, Paul. I believe you have a last question.
Yeah, so a
short,
comment and a
one.
quick question, and this is going to have to be a fast round robin because we're almost out of time. So awareness is the first step. You guys did a tremendous job presenting the possibilities and opportunities. What about, and this is quite a question for the cities on the line too, how best, in your opinion, can the awareness and the integration between all these different parts of a city, the utilities, the roads, they come together to share the knowledge and the awareness and the location of existing fibers and future planning fibers? That's more of a paradigm to make this happen. But just a quick round robin. Let's start with you, David. How can this happen?
Yeah, it's very complex because a lot of the providers consider their infrastructure confidential, and one reason is for security reasons. But if we were to get together and talk about this, and we could do it with NDAs in place, we certainly need the regulatory body to be on board with this as well, because that's stopping a lot of this type of conversation. So regulation is super important.
Thanks, David.
I would
Kyle?
say forums like this, Paul, and events and think tanks and industry associations and thought leadership exercises to bring people together in the various ways possible to communicate and discuss what are the best city planning options available? You know, we've talked about communications infrastructure today, but you know, there's many more categories to discuss. So these kind of forums, I think, are invaluable.
Kyle, final word before we close.
Education of people who are in the seats of a network operator, network owner, network manager, helping them understand all of the various applications that can be deployed are going to help them prepare their network for those applications, which will help private industries and public industries realize new types of revenues. When you have new types of revenues and cash is on the table, all of a sudden everyone's eyes open up and say, let's do this, right?
Thank you for that. Thank you all for being with us today. I would like to invite you to the next 2 sessions in November, focus on national policies for urban resilience and nature-based solutions. And we will after share the recordings of the series. Thank you so much.